Examples where we use the distributive property to help us solve an equation. So in this first example, we have a rectangle with one side 5 units, the other side 1/2 of x plus 1 units. If we know that the area of the rectangle is 15 square units, then that means that the length times the width will be 15 units. In ours, it doesn't really matter who we call the length and who we call the width. However, normally, because the 5 is by itself, that will go before the expression that's written in the parentheses. That's the way we're used to seeing the distributive property. And we know that the area then is 15. Using the distributive property and multiplying, we end up with 2.5x plus 5 is equal to 15. Subtracting the 5 from both sides, we get 2.5x is equal to 10. And then dividing 10 by 2.5, we end up with x is equal to 4. If we substituted x is equal to 4 into that expression, half of 4 is 2, 2 plus 1 is 3, and then this side of 3, this lower side of 3 times that right side of 5 gives us an area of 15. Trying a new example, we're going to use the same original length and width, but this time we know the perimeter is 24. Perimeter requires that we have 2 lengths and 2 widths. Again, not really mattering who's who, just as long as there's 2 of each of them. This first multiplication does not require the use of the distributive property. However, the second one does, because there are 2 terms inside of that second parentheses. Combining what we need to combine, we end up with 1x plus 12 is equal to 24. Subtracting that 12 gives us that 1x is equal to 12, which of course is the same thing as x is equal to 12. Area requires that we multiply the length and the width. Perimeter requires that we have 2 lengths and 2 widths. Add them together, knowing that it's 24. Let's try another example. Aaron, Blake, and Jacqueline are going to an amusement park. The cost of admission to the amusement park is $39.95 per person. Once they are in the park, the friends ride the race cars, which require an additional fee. If the total amount spent by all 3 boys is $143.70, then what is the additional fee to ride the race cars? So clearly we are being asked for what is the additional fee for the race cars. Each person owes the same amount. Each person owes $39.95 for admittance to the park, and each person owes X, the additional fee for the race cars. That means that 3 individuals are each paying for both. Could we separate this and write it as 3 times $39.95 and 3 times X? Yeah, we're eventually going to get there. But if we know that one person's entire cost is $39.95 plus X, and there are 3 individuals going, the distributive property allows us to write that all in one step. Multiplying out, we get $119.85 plus 3X is equal to $143.70. Subtracting $119.85 from the left and the right leaves us with 3x is equal to $23.85. The 3 additional fees that they have to pay are a total of $23.85. So what's each one? Well, we divide by 3 and we get that each one is $7.95. In our last example, we have a similar situation, except this time we're going to see a negative be used to represent part of part of something not being done. So here we have Denise must complete 4 late homework assignments. Here's her 4 late homework assignments, numbered 1, 2, 3, and 4. She decides to do all but 5 of the questions on each assignment. She ends up having to finish a total of 124 questions. How many questions were on each original assignment? So X is going to represent number of questions that are on each assignment. So in an easy situation, we would just say, well, this is X, and this is X, and this is X, and this is X. There's 4 of them, 4X is 124. But because Denise makes the difficult decision to skip 5 of the questions on each assignment, we can't simply represent our multiplication as 4X. Instead, it's actually 4 times X minus 5. Here's the number of assignments, 4. Here's how many problems she's going to do on each, X minus 5. They each started with X. She took 5 off of each one. Multiplying out using the distributive property, here is what she would have originally completed, 4X. Here's the 20 total questions she skipped for a grand total of 124. We add back on the 20 questions she would have skipped and say that the 4 regular assignments were a total of 144, and because they are all the same, we divide by 4, and we end up with X is equal to 36 questions. Did she do 36 questions on each assignment? No. She did 31 questions on each assignment because she elected to skip 5 of them on each one. These 3 questions each serve a similar function where there's a multiplication preceding the use of a multiplication that requires the use of the distributive property. Sometimes it shows up in geometry, where maybe we're doing length times width, or 2 times a length. Maybe it shows up because we're seeing something repeated, whether it's buying tickets to an amusement park or doing homework assignments. But we're very careful about what we're adding and or subtracting inside of those parentheses. It's not always going to be as obvious as an extra fee is more money. Yeah, that's what happened with Aaron, Blake, and Jacqueline, but it's not what happens down here. We want to reflect the fact that she did less questions than she was originally required. So as you're writing your own equations, just keep in mind, is that extra amount that's in the parentheses an extra amount that I need to add, or is that an extra amount that I need to subtract?